Good morning, young people. This formula chart y'all got yesterday, we will only be looking at the first, like basically what's on the screen right now, for now. But all these formulas we will be using in together for the rest of the year. But we're just going to start off with our basic ones: secant, cosecant, cotangent, which just means that they are reciprocals. So secant can be written as 1 over cosine. Cosecant can be written as 1 over sine, and cotangent can be written as 1 over tangent. Though we don't use this one very often because we have other options here, we can also write tangent as sine over cosine and cotangent as cosine over sine. And then the reason that these become helpful is because if we start writing everything in terms of like cosine and sine, which is usually the approach I will take, then we can simplify a lot of stuff out. The other nice thing is what's called the Pythagorean identities, and basically they state that whenever you have a sine squared plus cosine squared of the same angle, that will always equal 1. It does not matter what it is, that will always equal 1. So I wanted to do a little activity with that, but testing, We also have rearrangements of these formulas. So all three of these, right, that's tangent squared plus 1 equals secant squared. These are all like manipulations. Both of these are manipulations of this original one. So if you take this whole thing and divide it by cosine squared, then this becomes tangent squared. This one becomes 1. And then this becomes 1 over cosine squared, which is secant squared. Right, so that's how these other ones come, is if you take the original and divide it. You could also do some rearranging. Okay, so that's another option. God, that light's terrible. You can also do some rearranging. So you can do, for example, maybe subtract sine from both sides. So you could say that cosine squared equals 1 minus sine squared. Okay, that's one option. And then you can also have that, you could say sine squared is equal to 1 minus cosine squared. So sine squared equals 1 minus cosine squared. And again, that's just from either subtracting sine squared from both sides or subtracting cosine squared from both sides. Another really powerful one that comes up a lot is actually if you multiply everything by -1, negative sine squared minus cosine squared theta equals -1. So this one actually will come up a couple times, and this one's a little bit harder to see, but it's basically just the opposite, right? So if sine squared plus cosine squared equals 1, then negative sine squared minus cosine squared has to equal -1. Okay, so let's apply a couple of these. I'm probably going to just work through the odds. So we're going to just try to simplify these expressions. Okay, that's tough. All right. So we're going to try to simplify these expressions. And when I say that, that's usually going to be, we're going to learn how to write this as one term. So first, I like to rewrite this in terms of sine and cosine. So secant is 1 over cosine. Secant is 1 over cosine. So I'm going to rewrite secant as 1 over cosine. Then I still got times sine. And so what happens there is if I put that together, that's going to give me sine theta over cosine theta. And we know that that identity is tangent. So now we can work towards that. And there we go. We took that nasty thing, secant sine, and realized that it was actually just tangent. That's basically what you're going to be doing, is taking these expressions and simplifying them to a single term usually. Alright, so this one is tangent squared minus secant squared. So if I go to the formula chart, tangent squared minus secant squared, hopefully you can see that if you subtract secant squared from both sides, right? So we subtract secant squared from both sides. And then we have to subtract 1 from both sides as well, right? Because this would just be like tangent squared minus secant squared plus 1 equals 0. And then I would subtract 1 from both sides. So tangent squared minus secant squared equals -1. And again, you can rewrite all these other variations of it, right? Like it might be helpful for you to have all 3 of these written on here, to have maybe this variation written on here. But so now I know that tangent squared minus secant squared is equal to just -1. So when I look at it, I should be like, oh man, that's a -1. Okay, which -1 is a much easier number. 4-year-olds can understand what -1 means. So that's what we want. We want to take something nasty and make it something neat. All right. This is the stuff that we looked at yesterday that I was really, really struggling with. So don't forget, you have two terms, and you're multiplying both of those. So some people call it foiling, but it's just multiplication. My biggest thing is draw arrows. So 1 is going to multiply to both of those, and then negative cosine is going to multiply to both of those. Okay, and then just write out all your terms, and then you'll be able to simplify something. So when we do this, we got 1 times 1. That's 1. We got 1 times cosine. That's cosine. So plus cosine. And then we got negative cosine times 1. That's negative cosine. And then the last part, we got negative cosine times cosine. So negative times a positive is a negative. Cosine times cosine is cosine squared. All right, so here's this beautiful, nasty thing. Hopefully you'll see that in the middle you got a plus cosine and a minus cosine this time. So you can put those together, but they will actually equal 0. And then you've got 1 minus cosine squared. So if I look at the identities that I wrote down, I know that 1 minus cosine squared is equal to sine squared. So I can just say that this whole thing equals sine squared. All right. So I want y'all to definitely do 3, 4, 6. And then for number 8, 7, that's going to just involve how comfortable you are with fractions. Let me skip those for a second, maybe put those on a separate video. Same thing for 9. Alright, so 10, y'all should be able to do 10 today. And y'all should be able to do 11. And 12, for number 12. Excuse me. For number 12, I would recommend multiplying here, like multiplying these out first, right? Simplifying, and then everything gets multiplied by a cosine. Okay, so y'all should be able to do those. You know what we'll do is we'll actually just leave the fraction stuff for when I'm there, because the fractions are going to get messy. So for today though, I will want y'all to do number 2, 4, 6, 10, 11, and 12. So again, you're just messing around with those identities, trying to figure out how to simplify that into one single term. I will see y'all tomorrow.